How to build a Blackgates Sweet Pea 5-inch gauge locomotive Part 20, performing a hydraulic pressure test on the boiler to find out how good or bad it is and to see whether or not a repair is a practical proposition. I bought this badly made Sweet Pea along with this boiler as a package deal. And I was told by the seller that this boiler was not from this Sweet Pea, it's one that he bought and it leaked. I have a box full of various sizes of blanking plugs. I need quite a few for this boiler. The hole underneath the boiler is for the blowdown valve, and this needs plugging, as does every one of the boiler bushes. On the back head, the fittings for the water gauge are 1/4 by 40. The hollow stay for the steam blower is also threaded 1/4 by 40. The two holes down near the bottom of the boiler are to hold the ash pan in place, and these are blind bushes and don't need plugging. When I was talking to the seller, he was saying, I think it's the front tube plate that's leaking, but having worked with miniature steam engines and boilers for many years, what I saw in the firebox tended to make me think this was not the case. It's discoloured at the bottom of the firebox. But really, no amount of guessing is valid in this case. I need to give the boiler a proper hydraulic test. The square part with 6 holes in it is the mounting for the regulator. One hole goes through to the wet header, the other one goes into the boiler, and the 4 holes around the outside edge do not go all the way into the boiler. This is how the regulator block is bolted in position. A good design feature of a Sweet Pea is the regulator block is removable as one simple unit. And another useful feature is the top hole in the block, the one that goes into the boiler, has been threaded. And I can quite easily fit a blanking plug into this hole. What I'm going to do though is just thread the hole slightly deeper. To do this, I used the plug tab corresponding with the thread that was already in there. After cleaning up the thread, I blew away any swarf using my airline. The bottom hole goes all the way through the boiler to the wet header at the front. The top hole goes directly into the boiler itself. This is where the steam comes out, goes through the regulator block where it's regulated and sent back down the other hole. A pair of steam grade silicone rubber O-rings are used to seal these holes when the block is bolted in position. Quite a good design. If this hole in the boiler is not threaded, then you have to make a metal plate to seal it before you can pressure test the boiler. I'm going to fit this thread adapter, which is 3/8 by 32 down to 5/16 by 32 threads per inch, and this is where I will connect my test rig to the boiler, because the union nut on the outlet pipe is 5/16 by 32. It's a good idea to make thread adapters and have them in a box with the blanking plugs, because you never know when you're going to need one. As I don't want any of the blanking plugs to leak, I'm coating them with Loctite 542 before bolting them in place into the boiler. This boiler is a bit odd. It has 2 1/4 by 40 thread inlets at each side, which is very useful. This makes it possible to fit 2 injectors, a hand pump, or a small steam-driven boiler feed pump, or even an axle-driven pump, which I'm not going to fit to this engine. I don't like them. That is, not unless they are twin pumps, and this design shows a single ram, which would make the engine sort of jump up and down as it was pumping. Because I'm using Loctite 542, I don't need to use copper washers, and I don't need to over-tighten the blanking plugs. The ones in the top of the boiler are quite substantial. This one is for the steam turret. After fitting the pipe from my test rig to the boiler, I can fill it with water. I've put a funnel in one of the holes, and I'm starting the filling process. It seems to take quite a lot of water. The boiler is bigger internally than you think. This water container is a bit dirty on the outside, but it's clean inside. Here's the pressure gauge of my test rig, and below that is a small tank which I need to fill with water. I'm filling the tank using some spring water that I normally drink, but this has been in the workshop for a couple of weeks. It is extremely important to make sure the boiler is full right to the top. There must not be any air whatsoever in the boiler, and here it really is full right to the top. A final application of Loctite 542 and the last blanking plug goes in place. Now the boiler is fully sealed and I can start the testing process. This really is not a difficult thing to do. It's important though not to rush this. I need the pressure to rise slowly and steadily, not all of a sudden. The rattling you can hear is just the ball valve in the pump jumping. It should settle down after a while. Here's a clip I showed previously, and I'm pretty sure that a leak will appear at the firebox end. In this clip I'm wiping away some water on the bench. It's really important to make sure you have the boiler on a dry surface so you can see any leaks. The water that I've just wiped away from underneath the boiler was due to the filling process and a slight overflow. I'm going to test this boiler to twice working pressure. I want the working pressure to be 90 pounds per square inch, so I'm pumping it up to twice that, which is 180. I paused just before the 180 mark to have a look and see if any leaks were appearing, and yes, there was a very small dribble inside the firebox, but very tiny. After this, I increased the pressure and took it all the way up to 180 psi and locked off the pump using the valve that's built onto it. It would be very easy to cheat on this video by just using freeze frame, but no, this is all in real time. Well, no, that's a lie really. It's running at a higher speed just to get through it, but what I mean is I'm not freeze framing to make it look like it's not leaking. Even though the video is running at a high speed, by using my stopwatch app on my mobile phone, you can see how long it's been on test, and it's sitting there quite happily at 180 pounds per square inch. This is nearly 5 minutes in. I turned the boiler around to have a look in the firebox, and yes, there was a tiny bit of water pooling in the bottom, and I could see where it's coming from. The good news is the leak is very small indeed, and I could get away with it, dare I say, by using an automotive product called Radweld, but I'm not going to do that. Here I'm marking the position of the leak by using my Proxxon motor tool with a wire brush. It's not a good idea to mark the position with a felt tip pen because any silver soldering would not stick to felt tip pen marks. I'm rebuilding this sweet pea for my friend James Evans. He's a volunteer at Tees Cottage pumping station. They have a miniature railway and the boiler tester there is going to be testing the boiler. So I think James is going to ask the boiler tester if he will fix the leak. And why is that? Because it's in the firebox. I have propane, but I do not have oxypropane or oxyacetylene. As soon as I put my propane blowtorch anywhere near this firebox, it just blows out. I could always buy an oxyacetylene set, but it would be a bit of a waste because I don't do a lot with boilers. I've removed the blanking plug from the blowdown hole, and here I'm draining the water back into the bottle. I did this a couple of times and then carefully placed the boiler, firebox first, into the acid bath. This is not strong acid, it's Kilrock K kettle descaler, but it should do the trick. I left the boiler in the acid for 24 hours. I'll show the result in a future video. That's it for now though. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.